Hello class, we'll start today with section 2.1, graphs of equation. And if you look at my notes, there are 4 objectives. Plot points associated with order pairs of numbers. Determine whether an order pair of numbers is a solution of an equation. Graph linear equations using tables. Graph nonlinear equations using tables. So we'll start with number 1, plotting order pairs. So in order pairs, an example of an order pair is 1, 2. 1 and 2's are called coordinates. And you might know it's saying that we have the term axis. Axis here means there's an x-axis and a y-axis. These are 2 number lines. You may wonder why there are 2 coordinates, right? The first one is for the x-axis, any number, like 1 right here on the x-axis. And number 2 right here is any number on the y-axis. So 2 will be 1, 2 up here. And 1 for x, right, would be 1 here. So there's a point 1, 2. Okay? And then let's see. Oh, make sure that this order pairs 1, 2 is different from the order pair 2, 1. They are different. So do not mix the order, okay? Alright, let's start with the example. Plot point 8. Okay. So you look at my note, page 1, you will see there are points 8, -3, -5, B, 1, 3, C, 0, 7, D, which is 0, -2, E, 5, 0, okay, F, which is -4, 0, and then G, 1, -7, H, -6, 4, and the last one is J, -3 and 3, okay? So we're going to plot the following points. Plot the following points. Okay, these represent, each of these represent a point on the plane. Okay, and this plane is formed by 2 number lines. One is called the x-axis, the other is the y-axis. All right. So plus first we draw x axis and y axis, okay? And where they meet is 0. We call the origin, is where these 2 number lines meet across. Okay, 0, 0. Now let's start with point A, -3, -5. This first coordinate right here is on the x-axis, okay? Second coordinates on the y-axis. So I'll start off with -3 right here. So -3 from the 0 on the x-axis. On the left is negative x-axis. On the right is all for positive x-axis. Any number that are positive is on the right of the x-axis. Any number that are negative is on the left of the x-axis. So -3 will be on the left, right? 3 units to the left. So 1, 2, 3. I hope I have enough space, so up to 7. Okay, I think it'll be okay. So -3, this is -3, and then -5, -5 on the y-axis. Now for y-axis, the top is for positive values on the y-axis. The bottom for all negative values on the y-axis. So -5 will be on the bottom. And 5 units from 0. 1, 2, 3, 4, 5. So -5 right here. So -3 to the left, 5 down, you will have somewhere here. Okay, so this point right here is 0.8. Okay, let's draw point B, which is 1, 3, right? 1 on the x-axis, positive 1 on the right of the x-axis. So it's 1 right here. Let me take this out. So 1 right here. 3 for the on the y-axis, it could be on the top of the y-axis because it's positive. So 3 unit up from 0. 1, 2, 3. Okay. So this point B is 1 to the right, up 3, which is somewhere here. Right? 1 to the right, up 3. So this is point B. Okay? And point C, 0, 7. 0 for x. This is x-axis, right? This point right here, where both meet, is where both x and y equal to 0. So x equals 0 is somewhere here. 0x. And 7 up. 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7. 7 right here. So 0, 7 up. So this point is for C. Okay? For point D, 0 in the first coordinates, so on the x-axis, 0 again. -2, so it's on the y-axis. Negative value, so below the x-axis. So down 2. So this is point D right here. X is equal to 0, y equal to -2. Okay? Now let's see. For E, 5, 0. So 5 for x. So positive 5 means to the right of x. So 5 units to the right. 1, 2, 3, 4, 5. Okay, 5. And then y is 0. So there's no changing in y. Then no, it doesn't go up or go down. So stay where it is. So just 5 units to the right. 1, 2, 3, 4, 5. And y equals 0 is here, right? Remember, where both y and x axis meet is where both x and y equal to 0. So this point right here is E. So we have F right here. -4, 0. -4 is x. So to the left, 1, 2, 3, 4. So -4 to the left, and y equals 0. So it could be here. This is where y equals 0. So this point right here is F. For point G, 1. So it's 1 here is for the x-axis. So it's positive is on the right. So it's 1 here. And for y is -7. So below the x-axis, all the y is negative. -7, so you go 7 units down. 1, 2, 3, 4, 5, 6, 7. So -7. So you have right here for point G, 1, -7. So somewhere here. Let me move the -7 here, make space for us. Somewhere here. So this point right here is G, okay? 1 unit to the right on the x-axis, and 7 units down because negative. So right here, point G. The last point is H. Actually, there's one more point here. So H is equal to x is -6. So this time, the first coordinates is negative, right? So it's going to be on the left of x-axis because it's negative. So 6 units, 1, 2, 3, 4, 5, 6. So -6 here. And 4 units on the y-axis. And positive, right? So it's go up 4 units. 1, 2, 3, 4. So to the left 6, right, and up 4. 1, 2, 3, 4. This is 4. So somewhere here, okay, 6 units to the left, and 1, 2, 3, 4, 4 units up, which is H right here, okay? And the last point is -3 and 3. -3 right here, for the x-axis, is negative, so it's on the left of the x-axis. 1, 2, 3, okay, -3 here. And for the second coordinates, it's on the y, so it pauses 3, so let's go up 3, 1, 2, and 3. So somewhere here. So this is point J. So far we drew A, which is -3, -5, B, 1, 3, okay. C, 0, C is 0 where x is 0, and 7 units up, which is C. D is 0 minus 2, so 0. There's no change in x, right at where both x and y intercept x equals 0, and it's going down 2 units, which is D here. E, 5, 0, so 5 units to the right, 1, 2, 3, 4, 5, and y equals 0, so it's right here where y equals 0. So this point E, F is -4, 0, 1, 2, 3, 4, 0, y. G is 1, -7, 1, and then because -7, you go down 7 units. So this part right here is G. H, -6 for the x-axis, so you go to the left 6 units, and then 4 for y, positive, you go up 4 units, got H here. The last point is J, x, -3, so to the x, on the x-axis, -3 to the left, and 3 for the y positive, so you go up 3. Okay, so this solution for this example. If you notice from my note, I understand it's hard to grab this. Make sure you keep track of the right pixel where each point actually is. I provide at the end of my lecture note drawing paper, so it help you with keeping track of each unit away from the x, away from the y, and where to intercept to generate a point. So it can help you with graphing. So this is plotting ordered pairs. Each of these are ordered pairs, and we just grab it on the x, y plane. Okay. Right. Next, we talked about number 2, quadrants. Now, we talked earlier, when the x-axis and the y-axis intersect, it creates an origin. It creates the origin, right, which is 0, 0, where both the first coordinate is x equal to 0, the second coordinate is the y equals 0. Okay, this part right here is 0, 0. We call the origin. Now, after these two number line, x and y axis intersect, it divides this whole plane to 4 regions. This is region 1, region 2, it going counterclockwise, okay, counterclockwise, region 3, and region 4, okay. Now, we don't call region, we call quadrants. Quadrants, region 1 is quadrant 1, and we use Roman numeral 1, okay. So quadrant 1 is region 1. Quadrant 2, using Roman numeral, region 2, and same thing here, quadrant 3, region 3, okay, mathematically we call it this way, and quadrant 4, This is number 4 using the Roman numeral. Okay. Now, if you notice, for this quadrant 1, it's bound by positive x and positive y-axis, right? So, you look at my note, it's saying that in quadrant 1, both coordinates of point are positive, meaning both x coordinates and y coordinates are both positive. So any point in this quadrant 1 guaranteed has the first coordinates x and second coordinate y positive. For quadrant 2, you know this is on the left of the x, right? So it's on the side where x is negative and x is the first coordinates, okay? And the y-axis is positive. So in quadrant 1, you will see point that has negative x, positive y. So negative first coordinates and positive second coordinate. For quadrant 3, you see that it's somewhere here. It bounds by negative x and negative y. So any points in this quadrant have both x and y negative. For quadrant 4, bounds by positive x, negative y. So any points in this quadrant 4 will have positive x, negative y. Now, let's try the example here. I have it determine if -2, 1, and 0, 5 are in quadrants. If they are, specify the quadrant number. Each point is in solution. Now, before I work on this example, let me give you an example, quadrant 1 example. Okay. 1, 2, both values, both coordinates, x and y, are positive. Quadrant 2, example, negative x, right? Positive y. So first coordinates, which is x negative, second coordinate is the y positive. Example for this one is negative x, negative y. So they're going to have both negative and y coordinates. For this quadrant 4, positive x, negative y. X is the first coordinate, was positive, right? 1, and negative y was just negative 2. This is just an example, okay? To help you visualize what it means for each quadrant. Just the example. It can be any points, infinitely many, any points in this quadrant. So for this example here, we have, let's draw it. The first point we have is -2, 1, right? -2 first is the first coordinate, which is the first coordinate is on the x-axis. So -2, which is negative from 0. So -2 to the left of 0. So -2 here. 1, so positive is the second coordinate, which is on the y-axis. Positive, so go up 1. So go to the left 2 units and go up 1 unit. It's the points right here. Okay. Now, using what we just talked about, quadrant. So for this point right here, what quadrant it is in? Quadrant 1 is the top right here, going counterclockwise. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. So this is quadrant 2, right? So actually, this point is in the quadrant.